Hello learners, today we are going to learn about Laplace transform. Laplace transform is one of the core subject of mathematics which we are learning from the degree level, and the Laplace transform is having its own application in the master degree level. That is we learn what do you mean by the Laplace transform and its application in the master degree level and in the doctoral level also. In the doctoral level, I means in the PhD level. So before defining what do you mean by the Laplace transform, let us see what do you mean by a real valued function. Let us see what do you mean by a real valued real valued function. Real valued function. A function a function f from set of to r r is which is assigning a real number, which is assigning a real number to each elements of its domain. What is that domain? That is a subset of R. Its domain is called as a valued called as real valued function. It's called as real valued function. It is assigning a real number because its a codomain is R. Its codomain is R. For example, f of x is equals to x for all x belonging to R. It will be a real valued function of x, that is equals to x square by 4 plus 8x plus 2 for all x belonging to R. It will be a real valued function, and we have so many examples. Now, so this was about the real valued function. Now let us define what do you mean by a Laplace transform of a function. Laplace transform. Let f of x be a real valued function. It be a real valued function defined for x greater than or equals to 0. It means that the domain of the function f, it is containing only non-negative elements. The meaning of this one, that is the meaning of this condition is that the domain of the function f is containing only non-negative elements. The Laplace transform of f of x, the Laplace transform of f of x is denoted by that is the L of f of x, and defined as this L of f of x, that is the integral from 0 to infinity e raised to minus of sx f of x dx, provided that the integral on right side exists. It means that the integral on the right side exists. It means that it must have some finite value. It must not be equal to infinite value. Where this s where s where s is a real or complex parameter. The parameter means it's a variable. The parameter means the variable whose value changes according to the time. It's a real or complex parameter. This thing we have to note that. This thing we have to note that the operator, the operator, the operator L is called as Laplace operator. It's called as Laplace operator. It is called as Laplace operator. Um, Laplace operator, and we can observe that. So we can observe that this L of f of x is equals to 0, the integral which is from 0 to infinity e raised to minus sx f of x dx. So clearly, when we integrate this one, we will get a value which will be in the function of x. Clearly, it is a function of x. We can write that clearly. The L of f of x 0 to infinity e raised to minus of sx f of x dx, because s is a parameter, is a function of is a function of function of parameter is a function of parameter. Yes, it's a function of parameter of s. So then we denote this as L of f of x 0 to infinity e raised to minus of sx f of x dx as function of the function of s. So this was some introduction about the Laplace transformation. If you are having any doubts, if you are having any query, please comment me in the comment section, and please like my channel. Please do subscription my channel, and please like my video, and don't forget to press the bell icon. Thank you, learners.